Steps to solve trigonometric ratios, part 1. I'm Anil Kumar, and this is such a vast and important topic for us to understand that really it may take hours for me to discuss and tell you different ways of solving trigonometric ratios. But in this video, what I'll try to do is bring few concepts together and then let us see how much we can cover. And then I think some spillover can go to part 2. We'll concentrate on primary trigonometric ratios. So that is to say that kind of sine A, for example, cos, let me write this as x, and let me write this as tan of theta. So I'm using sine A cos x tan theta just to tell you that always this angle is not x or theta or something. It could be anything, right? So trigonometric ratios which we are considering now are primary trigonometric ratios, which means sine, cosine and tan. So let's begin by taking a right triangle to begin with. That's a good starting point. So if I have a right triangle, let us say this is my right triangle, and I'll take very simple examples. And let's say this triangle has sides 3, 4. You can always find the third side. 3 square plus 4 square square root, which is 25 square root, which is 5. You all know 3, 4, 5 is a good triangle to start with. Sine A, let's calculate. So let me call one of the angles as A. Let me call this triangle as ABC, right? You will come across similar examples. So we want to know sine A. So that is our first question. How to find sine A? Now, to find these ratios, we should know what they are. So first thing is Sohcahtoa. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, right? Now since I want to calculate sine A in a triangle, then I can always find the ratio of opposite over hypotenuse. So let me write it in short, opposite over hypotenuse, and for this given angle 4 over 3, right? So opposite to A is 4 and hypotenuse is the longest side, 4 over 5, right? 4 over 5 is sine A. So I found the trigonometric ratio sine A. That is what we mean when I say steps to solve trigonometric ratios. So these are the steps. Look at the triangle. From the definition you can find. Now at times we will just extend this a bit more, and that is we will say how to find angle A, right? So sometimes we'll have a question, solve for A, right? That means the angle A measurements you need to find. Well, in that case we can say that the angle A is equals to sine inverse of 4 over 5. So for that you can always use your calculator. So second function, shift sine inverse within brackets 4 divided by 5 bracket close equals to 53.130. So we get one answer which is 53.130. At times you may be required to round it to the whole number. So let's round this time to the whole number. So it is 53 degrees. It means that the angle A is 53 degrees. So that is solving for a triangle. Once you know angle A, you can find all other angles, correct? Now as an exercise, you can find what is sine of C, right? And then other ratios for the given triangle. But anyway, one way to solve for trigonometric ratios is using the right triangle itself. Now let me discuss another way of solving trigonometric ratios. And this time I'll take a coordinate point. So at times we say that we have a point which is, let us say 2 and 5. Okay, so that is the point given to us, and we need to find the trigonometric ratios which are related with the principal angle. Principal angle is measured from the positive x-axis, and let me call this angle as theta. Okay, now if you have this kind of a situation, then what should we do? In this kind of a situation, what we do is, from this point we drop a perpendicular, and we know 2 means the x value, 5 means the y value. So we need to find the hypotenuse in this case, which should be equal to, let's write down let me call that as r, as we normally use r, will be square root of 2 square plus 5 square square root. So let's use the calculator once again, which is square root of 2 square plus 5 square square root. That gives us square root of 29. Writing square root of 29 is writing in exact values, correct? So now in this case, we can say, well, for this particular triangle, one of the trigonometric ratios, I will use tan theta this time, that tan theta is equals to what? Tan theta is opposite over adjacent side, right? Opposite over adjacent side. So it is opposite is 5 and adjacent is 2. So get 5 over 2, which is 2.5. Well, we can find other trigonometric ratios also. Let's find cosine of theta. Cosine is adjacent over hypotenuse, right? So it is adjacent over hypotenuse, and that is 2 over, we found hypotenuse as square root 29. So 2 over square root of 29. So that is how we can again calculate the trigonometric ratio. Now it is a good practice never to write square root in the denominator. In that case, you may be required to rationalize it. So rationalize means multiply and divide by square root of 29. So that is what rationalization is, right? So then what the answer you get is 2 square root 29 divided by 29. Well, it looks kind of odd, but that is the way you have to write your answers at times. Now as an exercise, you can solve for other trigonometric ratio, that is sine of theta for this particular triangle, correct? So this is how at times when we say find trigonometric ratios, we mean basically to use Sohcahtoa to find these ratios in such cases, correct? So at times we may have a different kind of a problem altogether where we are given one trigonometric ratio and you need to find the other. For example, if I am given that cos theta is equals to, let us say, 7 over 9, and the question is find tan theta. So that is another type of question which you can come across. Now in this particular case, you know what cos theta is. Cos theta is 7 over 9. That really means that if I draw a right triangle, in that case 7 is my adjacent side, 9 is the hypotenuse, theta is the angle. So what we need to find is the third side, which you can find from, let's say b. So we say b equals to square root of 9 square minus 7 square square root. So let's find it. So we get what? We get square root of 9 square minus 7 square equals to square root, well, exact value is 4 square root 2. So we know b equals to 4 square root 2. Once you have three sides of right triangle, you can use Sohcahtoa, you know what ratios are, and find tan theta. So tan theta now for you should be opposite over adjacent, which is 4 square root 2 over sine. So that is the exact value of the trigonometric ratios. Well, in this part, we will discuss these three methods of finding trigonometric ratios. While these are very versatile and useful methods, I hope they help you to solve trigonometric equations also. Thank you and all the best.